So this is lesson 4.2. I hope you don't mind the black. It just seems so much cleaner to draw on a blackboard. I guess maybe because I'm old and I'm used to chalkboards. But anyway, that's what we're doing right now is the blackboard. So I hope it works for you. And in this section 4.2, addition and subtraction with decimals and pre-algebra, what we're doing here is just reviewing how to add and subtract these decimals. First of all, one of the things that we need to do is, well, in fact, let's look at example 2. They give us 39.812 minus 14.236. Okay, so really difficult to subtract that way, because we like to subtract vertically. So the key thing when you're subtracting or adding decimals is making sure your decimals line up. So try to really work at making it pretty. When I first teach decimals to elementary students, a lot of times I'll give them graph paper so they can put each digit in one of the little squares of the graph so they can make sure everything lines up. And one of the things that I teach when I teach this to kids is I make them put their decimal right there so they know where it is. It is in line with the other two parts of the subtraction. All right, so let's go ahead and subtract. So if you remember, you have to do your whole borrowing thing where this is in the tens place, and that's a number 11 because it's a 1 plus 10 is 11. So this will change to a 10. This will change to a 12. So we have that. 10 minus 3 is 7. We borrow from here, and we get a 5. 9 from 4 is 5. 3 from 1 is 2. I'm not going over all the details about borrowing and all that. I do it one way, so other books do it other ways. I'm sure you were taught a particular way, and I think we went over that back in the very beginning of the textbook, the review section. So anyway, let's look at some addition. Example number 3. Get rid of that. And number 3 has 8 plus 0.002, sorry, I'm a little sloppy here, plus 3.1 plus 0.04. Golly, it's getting bad. All right, so let's line everything up. 8, there's a decimal there. This one here, we're going to put the decimal there, and 002. This one, the decimal there, and there's a 3 over here, and a 1 there. That one, there's a decimal there, and there's a 0.4, and there's nothing to the right. Now, what a lot of students do, and I don't really care one way or the other, is if you fill in with zeros, and it just makes sure not only that everything is lined up, but what in the world do you do with these numbers? All right, so let's go ahead and add up this column. This column, not real straight, this column, and then 8 plus 3 is 11, and you're done. All right, subtraction is the same way. So if we look at example 4, we've got 5.9, and it's asking us to subtract 3.08, so I put my decimal there, I put my 3 there, 0.814. And again, if you put a 0, let's do it in red here again, just to show that they weren't there in the beginning. Then I have something to take my 814 from. So 10 from 4 is 6, 9 minus 1 is 8, 9 minus 8 is 1, that 9 turns into an 8, and I get 2. All right? So, example 5 is a little bit trickier. What they're saying is subtract 3.09 from the sum of 9 and 5.472. So this is kind of like a story problem. They want to take the sum of 9 and 5.472. So there's the sum of 9 and 5.472. We just haven't added them yet. And they want us to take away 3.09 from the sum. So we go ahead and add these two. And then that answer, we take away 3.09 from. Example 6. We have negative 4.75 plus negative 2.25. And our signs are the same. And it's just we're adding. So whenever our signs are the same, we add the two numbers up. We get 7.00 or just 7 or 7.0, whatever you want to do there. And you put the sign of the numbers on there and that's it. But when you have one like example 7, 3.42, which is positive, plus, and now we've got a negative. Signs are different. You take the difference between the two, and again, this is where a calculator comes in handy, and you put the sign of the largest number on your answer there, and that gets you through example 7. Now, as an old guy who grew up during his teenage years working at a drugstore, running a cash register on many occasions, and not having computers, or any technology for that matter, we had to actually count back change to people. Nowadays, when you go to a store and you find something and you pay for it, most of the time, if you notice, especially at McDonald's or someplace, the kid there will take a half hour trying to figure out what he owes you, because the cash register may say they owe you $4.27, and they not only have a hard time coming up with what that is in dollars, quarters, dimes, nickels, and pennies, but they can't count it back. So they just kind of hand you this handful, this wad of money and change with no idea whether or not they gave you the right change. They're just going by what the cash register said to give you. Now, when I was a kid, yeah, it's one of those things where I went to school in the winter, barefooted both ways, uphill kind of story. But when I was a kid, the cash registers did not tell you how much change to give back to a person. It gave you a total, like $14.27, and you had to figure out how to give back the right amount of change if somebody were to give you a $20 bill. So example 8, I'm sorry, that little story there, although just to get you going on example 8 here, talks about going to a coffee shop and having lunch, and the bill was $15.64, and he gave them a $20 bill. Now, real easy to do this. $20 minus the $15.64 to find out how much money you were supposed to have. But when I was a kid, what they did is they would give you that $15.64, and I would count to myself. They gave me a $20 bill, and it came to $15.64. I would give them a penny to make it to 65, and then a dime to go to 75, and then a quarter, and that would mean now we're up to $16. And then I'd give them 17, 18, 19, 20. So I'd give them then dollar bills after that. So I'd give them $4 bills and go from there. So it's real easy for me to do these story problems, but for those of you that have grown up with technology, you've gotten kind of used to not having to do that. So what he says is he got 4 $1 bills, a quarter, a nickel, and a penny back. So he's wondering if he got all the money that he should have. Well, if you look there in the solution, he tells you how much money he got back. 4 $1 bills, a quarter, 1 nickel, and 1 penny, and he added all that up and said, oh, I got $4.31 back. Is that right? No, because he should have gotten $4.36. So, the coffee shop barista was a nickel short on the change. He should have gotten a dime instead of that nickel, so he was a little bit short there. So, anyway, just some real life story problem using decimal kind of things here. So that's it for lesson 4.2.